Okay, here we go to the solutions to the basic skills revision sheet 4. Let's start with question 1. Write 56 as a product of primes in index form. So 56 is equal to 7 times 8. We're looking for a product of prime numbers. That means multiplying only prime numbers together. Now 7 is a prime number, but 8 isn't. 8 is equal to 2 times 2 times 2, and they're all prime numbers. So that's going to be in index form 2 to the power of 3 times by 7. We could have 7 times 2 to the power of 3, but it's better to write the small numbers first. Okay, the second question. Find the LCM, lowest common multiple. So the multiples of 12 and 18. So 12, we go 12, 24, 36, 48, and so on. 18 is 18, 36, and so on. But we have our lowest common multiple, which is 36. Increase 97.50 by 4.5%. So to increase by 4.5%, we need to times by 1.045. If we start with 100% and add 4.5%, we get 104.5%, which is the same as timesing by 1.045. So we take 97.50 and we times by that. So we get the calculator out. 97.5, don't need the 0, times by 1.045, and that gives us 101.89 to the nearest pence. A Venn diagram question. In a class of 40, we have 23 have a brother, 31 have a sister, 3 have neither brothers or sisters. Fill in the Venn diagram to represent this information. So 3 have neither brothers and sisters, so that goes around the outside. We have 40 people in total, but we've just used up 3, so that leaves us with 37. And we have 23 that have brothers and 31 have sisters, so that's 54 that are going to be represented in this area for brothers and sisters. Now that's more than our 37. The overlap, how much more, is how many are going to go into the middle, because they're going to be counted twice. So if we work out 54 take away 37, which is going to be 17, that's how many we need in the middle. And then we need to work out how many people have brothers. So 23 have brothers, so there's another 6, because 6 and 17 makes 23, and there are 31 have sisters, so we need to add on 14 to make a quota of 31, and that should add up to 40 in total. Right, 40 as the sum of 2 prime numbers in at least 2 different ways. Okay, so essentially we're just looking for 2 prime numbers that add together to make 40, and we've got to try different ones to do that. So let's write out some prime numbers. There's our first 4. Remember, 9's not a prime number. It helps if you know most of these pretty quickly. And we need to go up to 40. So if we start with the biggest one, 37, what do we add to 37? Well, we could add 3 to 37, that makes 40. 31 would be plus 9, that can't be because it's not a prime number. 29 would be plus 11, so 29 plus 11 makes 40. And they're both prime numbers, so that's 2 different ways, but there is another one. Let's just see if we can find it. 23 plus 17. So any one of these 3, well, any 2 of these 3 ways would be correct. What is the exterior angle in a regular decagon? Okay, so in a regular decagon there are 10 sides. So the exterior angle in a regular shape is 360 divided by the number of sides, which is 36 degrees. And question 7, we have 2 numbers written in the product of primes in index form. We want to find the highest common factor. Highest common factor, HCF, of A and B. So the highest common factor will be a combination of the lowest powers of each prime number. There's going to be a common factor, it has to be in both. So we've got 2 squared and 2 cubed, so the lowest power of 2 there is 2 squared. And then we've got 3 squared, we haven't got any 3's in here, so the lowest power of 3 would be 3 to the power of 0, or just 1, so that's not actually going to be in both. And the same for 5, that's not in both, but there is a 7 in both, and the lowest power of that is 7 to the power of 1, or just 7 on its own. So we've got 2 squared times 7, which is the answer, but if you wanted to know it as a number, that would be the same as 7 fours, which is 28. Question 8. A tree has a height of 73 centimetres and increases by 2.5% each year. How high would it be after 5 years? So all we have to do here is to think about the multiplier. We are doing 100% plus 2.5 each year, which is 102.5%. And that equals a multiplier of 1.025. So if we multiply by that each year, we will get the answer. So we start with 73, and we need to times by 1.025, but we're going to do that for 5 years, so times by that 5 times. But much easier to use the power of 5. You can do times by 5 each time, but using the power of 5 makes things a lot simpler. So we've got 73 times by 1.025 to the power of 5, and that's going to be equal to 82.592799954, and we could round that to whatever degree of accuracy we're asked to, but in here we're not, so we just leave it. Find the area of a circle with diameter 18. The area of a circle is equal to pi times the radius squared. Diameter is 18. That tells us that the radius is half of that, which is 9. So pi times 9 squared. 9 squared is 81, and leave it in terms of pi, that means 81 pi. Calculate the volume of a cylinder with height 12. So the volume of the cylinder, we're going to use again the area of a circle formula. So if we have a cylinder, we need to work out the area of the end, which is a circle, times by the height. So it works just like a prism, even though it's not quite a prism. So the height is 12, the diameter is 8, so the radius is going to be 4. So we want pi times the radius squared times by the height. So pi times by 4 squared times 12, which is pi times 16 times 12. And again, we want to leave it in terms of pi. We can use the calculator if we want. It will actually leave it in terms of pi if we type, even if we type it in. So pi times 16 times 12, if you have it in the right mode, that is. It's 192 pi. Okay, question 11, solve an equation. This is a grade D equation. All we've got to realise here is to make x on its own, we need to undo this divide by 7. And the way to do that is to times both sides by 7. So we times this side by 7 and this by 7. That cancels with this to give us with x equals 4 times 7, which is 28 over 5. 5 is going to 28 5 times with 3 left over. So that could be our answer. If you're desperate to put as a decimal, you put 5.6. Factorise this completely. Careful not to think this is going to be a quadratic where you have double brackets. This is only a single bracket factorisation because there's no number on the end. First of all, we deal with the numbers 3 and 12. Well, 3 goes into both 3 and 12. There's a plus in the middle. What else goes into both of these? Was an a in both, so we take out a factor of a. What we've got left, well, what do we times 3a by to get 3a squared? Well, that's just a. And what do we times 3a by to make 12a? Well, that's just 4. So we have 3a is our factor, and a plus 4 goes in the bracket. Let's just rub out that little line there. This one is a proper double bracket factorisation, so we're looking for a double bracket that factorises to give us this. So we're looking at what multiplies to give us 30. We've got 1 times 30, we've got 2 times 15, we've got 3 times 10, we've got 5 times 6. and then we need to add to give us minus 17. So these must all be negative numbers, because when you multiply two negative numbers you get a positive number, which is the positive 30. We need to add to make minus 17, which would be these two, minus 2 and minus 15. So minus 2, x minus 2 and x minus 15. You can write that either way around, so you could have the x minus 15 first or at the end. Solve this equation. This is sort of a grade B type equation with the numbers on the bottom looking like a fraction. If we find a number that multiplies throughout, to get rid of these numbers on the bottom, such as 6, and we times each bracket by each part by 6, then we get 6 times this first bracket. 6 divided by 3 is 2, so we've got 2 lots of 5x minus 4. Take away 6 divided by 2 is 3 lots of 3x plus 2 in a bracket equals, and this is the bit that most people forget, is to multiply this side, 6 lots of 31, which is 186. Multiplying out these brackets we get 10x minus 8, and then we'll be careful with these subtractions here. So minus 3 times 3x is minus 9x, and minus 3 times 2 is minus 6. Okay, normally I'd work down the paper and run out of space here, so 10x take away 9x is just x. Minus 6 is minus 14. So that tells us that x equals 200, because we add the 14 to both sides. Okay, x squared minus 4x plus 9 in the form a minus x all squared plus b. This is called completing the square. We've got a hint here that it's minus a, so that's going to help us. So the thing to remember here is that because it's x squared, it's going to be x. This number is going to be halved and put in here to get minus 2. So that's part of it, that's the minus a bit. And then we've got to remember when we multiply out this bracket, we're going to get minus 2 times minus 2, which is minus 4. So I'm going to take away the minus 2 squared, which is going to be 4, because I want to just leave myself with 9. So let's just tidy this last bit up. So that equals x minus 2 all squared. And we are taking away 4 and we're adding 9, so that's the same as adding 5. Solve this by factorising. So again, double brackets, making it equal to 0. Single x squared. What times to give us 40? So we've got 40 times 1, 20 times 2, 10 times 4, and 5 times 8. But we're gonna, one of them's got to be negative because we've got a negative value here, and it's going to be the bigger one's negative because when we add them we're going to get minus 6. So we want two that are minus 6 apart, and that's going to be minus 10 and 4. So you can have minus 10 and plus 4. It doesn't matter which way around they are, but what we need to do now is to make each bracket 0. When we make those brackets 0, that tells us what x is. So the first bracket, x minus 10, if that's equal to 0, that tells us that x equals 10. Or the second bracket is 0, x plus 4 equals 0, so that tells us x is minus 4. So we've got 10 or minus 4. Question 17. Write down the 10th term of the sequence x squared plus 3x. Okay, really should have put this as n squared plus 3n, but it doesn't really matter. We're doing the 10th term, so whatever the variable is, we're making that 10. So we're going to make it 10 squared plus 3 times 10, which is going to be 130. Simplifying this expression, this quotient, we need to factorise the top. Been quite a lot of factorising on this sheet so far. We've already got x plus 2 on the bottom. That might be our hint, because if it's going to cancel down, there's got to be an x plus 2 on the top. It's quite an easy factorisation. What multiplies to give you 12? Well, 1 and 12, 2 and 6, 3 and 4. It's got to add to give us 8. So 2 and 6 are our two factors, and clearly the x plus 2 cancels to leave us with x plus 6. Question 19. What is the angle A? Well, this is a regular pentagon, the marks tell us that. And in a regular pentagon, the exterior angle, so that's the line coming off the side, that angle in there, which is the exterior angle, is going to be 360 divided by 5, which is going to be 72. This angle is also 72 because it's also an exterior angle. So we know that 72 plus A equals 180. So we've got 144 plus A equals 180. So A equals 36. Question 20, work out the nth term of this sequence. So this sequence is going down by 3 each time, so it's based on the -3 times table. So if we write down the -3 times table, -3, -6, -9, -12, and so on, and we're trying to get to 20, 17, 14, and 11, and so on. So what have we got to do to -3 to get to 20? Well, we've got to add 23, and then check this one. -6 plus 23, -9 plus 23, and -12 plus 23. So it's going to be the -3 times table, -3n, and then we're going to add 23. So this is going to be -3n plus 23. Now that could be written as 23 minus 3n, or -3n plus 23. Question 21 to 23. Question 21, a nice basic grade D question. You got to know one of these three statements. In alternate angles are equal, corresponding angles are equal, or interior angles up to 180. So what is P? Well, this shape here is a Z shape, and that is the rule that they are alternate. So alternate angles are equal tells us that P equals 26. This question, right angle triangle, missing side, it's Pythagoras' theorem. That tells us that the sum of the square of the hypotenuse, 23 squared, is equal to these two squared, so 16 squared plus D squared. So these two added together. 23 squared, let's bring in the calculator. 23 squared is 529. 16 squared, I think that's 256, let's just check. Yep, 256 plus D squared. Now this is where most people make a mistake. Because this is the largest side, we need to subtract the 256 from 529. So 529 minus 256 is equal to D squared. So we need to do 529 minus the answer. So that's equal to 273. So D is the square root of 273. Square root of the answer. And that's in the third form, but to the nearest to three significant figures, we'd have 16.5. First, second, third significant figure. Question 23. This is a circle theorem. This circle theorem is to do with tangents to the circle. This distance here between here and here and here and here, so C to D and B to D, if they are tangents, that is equal. So these two lines are equal. This forms a kite with the two radii. So, and we know that these two are 90 degrees because tangents are always 90 degrees to the radius. So what we have here is a quadrilateral where A plus two lots of 90, which is 180, plus the 40 equals 360 because it's quadrilateral. So we've got 220 plus 360, sorry, 220 plus A equals 360. So A is 220 from 360, which is 140 degrees. Okay, the last two questions. Question 24, area of a triangle, of any triangle. If we have an angle and two sides either side of that angle, we can then use that. If we call this angle, we call this C and this B, and this A, then the area equals a half AB sine C. So we've got a half of A, which is 16, times B, which is 20, times the sine of 35 degrees. And we can just type that into the calculator, and that gives the answer. So a half times by 16 times by 20 times the sine of 35. Make sure there's a little d in there, or it says degrees. It's in degrees, and we get 91.77, but to one decimal place that would be 91.8, and this is centimeters squared. The last question is a vectors question, question 25. We are told that the vector OE is E and the vector OD is D. M is a point on ED such that D to M is 3 and M to E is 1 in a ratio of 3 to 1. Find OM in terms of E and D. So we want to find this vector in terms of these two. So what we need to do is we need to get onto the line. Now we can either go via E or we can go via D. We're going to go via E. We need to start by doing E and then a fraction of this line, which is ED. So we're going to add E to D. And what fraction do we want? We want 1 out of 4. So we want 1/4 of ED. Now ED is going to equal minus E plus D, or D minus E. So we want 1/4 of that, so 1/4 of ED is going to be minus 1/4 E plus 1/4 D. So we've got our, this is OM we're trying to find, that's equal to E minus 1/4 E plus 1/4 D. So E minus 1/4 E is 3/4 E and plus 1/4 D. Doesn't matter which way around you write that. We can have the 1/4 D plus 3/4 E, or 3/4 E plus 1/4 D. And that's it.